I'm here and I'm happy to be here with all of you. Thanks for coming. Thanks to myself for waking up just in time. So this is about colors, pdfToolbox 11, and there are basically a few topics that I want to cover. The first is RGB to gray conversions. Second, so more control when it comes to converting. I had that on the first day, converting RGB gray to CMYK gray. So we give you more control about what's happening there. More control via variables for convert colors. 2 new fixups related to color mapping. So mapping one color to the other. There you have more control, or you can better use variables. And then something about overprint issues when you convert spot colors to CMYK. There is a new process plan for that. First, just a very short remark for the Germans amongst you. So far, for spot colors, we had used the term Schmuckfarbe, which is kind of old-fashioned. We stayed with this term up until 11, but now we decided wherever we had used the term Schmuckfarbe, that is now replaced to Sonderfarbe. So if you use the German UI and you search for finding a profile with a spot in its name, then you should switch from using Schmuckfarbe to Sonderfarbe. So but now RGB to gray. So when you have RGB color and you want a vector graphics or so that is using RGB color to CMYK, and this vector graphics happens to use something that is gray or black, then in RGB there is no indication, no real indication. So because in RGB, red, green, blue, you can't have black or gray. So if you have a color that should appear black or gray, then this is indicated by the same value in the red and the green and in the blue color run. So, and then if the same value is there, if there is 50 and the 3 of them, then you have a gray. But when you then convert that to CMYK, you have to make a decision, because in CMYK you want this gray to appear only in the black channel. So you have to make a decision there. What is the tolerance? So is a color patch or a vector color that is using 49, 50, 51, is it still gray or is it not? In our engine, so far we always use 2% as a tolerance here. But it turned out in support that sometimes you want to use a different tolerance. So what we introduce is there is a new check which is called difference between color channels, that allows you to find objects with that are close to each other but are not the same or are the same. And via this property, you can find objects that are within the specified tolerance, convert them to gray, and then convert the rest to RGB. And that is what's happening in this new process plan. So when we open, I have created a test chart here. Yeah. And it has, okay, we should use Object Inspector. And in the middle of it, here, not yet there, here, we have a patch with 50, 50, 50, so that has 5% in RGB color, and the rest of the patches just goes in 2.5 in 2.5 steps to the, you can't read that anyway, but it doesn't matter. So what you, it goes in 2.5% here towards red, then to green, and here is the blue axis, right? So we just go away from the pure gray to color. And I need to go to the right library here. And here, this is a process plan. Convert RGB to CMYK with specified RGB tolerance. And then when I run this, it comes up with a question. Then I'm just setting it to something dramatic so that we can see something. So we're setting the tolerance to 20%. Saving the result, and now it has converted many of the other patches here to gray first, and then the rest, it's all here, you see it over here, it's all CMYK now. It was RGB in the middle here. Click to freeze. Yeah, it has converted to 0.412% for dot gain that was in the profile, and that yeah, these others have slightly different values then. Okay.
What is the reason of a process plan?
Now, because in the first step we convert only the, in this case, color patches, the colors that are in the specified tolerance, and then in the second.
So what would happen if you had, is it two separate fixups, or is it
the
same fixup configured in a different way?
It's two.
So what would happen if you had both fixups in one profile? I would assume it's a method of the quick conversion. The quick conversion.
No, it's regular color conversion. So what it does here in the first step, it converts everything to dot gain 20%.
Okay, so it's the same fixup but with a different configuration.
Right.
Okay, that is. I'm okay.
Yeah. Yeah. Okay. If you would use two, then you would have to exclude the one. Yeah. Okay. Next. Yeah, more control for convert colors. What is new? We have a new section here in convert colors, which is called advanced settings. And that, maybe we should just have a brief look here. Create fixups. So this is for the ones who have been using convert colors before. There always was an entry here, use a color conversion policy, which had specific parameters. So for the advanced color users, there were certain additional parameters for the color conversion. This has gone away, and it's now here in advanced settings. And it basically has all the options that were available previously via the color conversion policy. It has all these options. So what options are that? So we have the new thing here with a plus button so that you could enter as many such parameters as you want. And the big advantage is for the ones who are using variables or JavaScript. Before it was a configuration file, which wasn't possible to adjust to the required settings. It's now possible because you can assign everything with a variable here via this orange triangle. So settings are, you can specify the rendering intent for the color conversion, and then as always in these settings, so we have 1, 2, 3, 4, 5, 6, 7 areas, and each area is then subdivided so that you can adjust it separately for CMYK vector graphics, CMYK images, RGB vector graphics images, and so forth, and also LAB. And then you can specify the rendering intent, the color space that you want to use when you convert black colors from the source color space to the destination color. For instance, as we've just heard, for RGB vector graphics, that would mean that R is similar to, or is the same as G and the same as B. And then you can say, should such a color end up in CMYK black, as we've just heard, or should it end up in separation black, which had some advantages when it comes to overprint, or should it be converted to device gray? So these are the 3 color spaces that you could use in a CMYK in a print product for black. And then these are all very special. You can exclude certain blend modes, so transparency blend modes. You can handle process colors in a separation color space or device CMYK color space. So you can say how these should be treated. Whereas separation can only have the cyan colorant, so when you have a single cyan colorant, an object that only uses cyan, should that be treated as if it would have magenta, yellow, and black with 0 or not? So this is a question that can be specified here. And then we are here, apply dot gain difference for advanced color conversion. That means I have a CMYK object and I'm converting to another CMYK color space. So let's say from uncoated to coated. Then with this setting, I can specify that the colorants are converted individually, so that the cyan, you wouldn't do a full new black separation. So every colorant would basically be treated separately, but the dot gain difference that is part of an ICC profile conversion would be applied. So very special, but it can be adjusted. I think this is the one that was mostly used in the policies, the JPEG quality. So sometimes what we currently use is always high, but sometimes you want to have an even better. Marcus is right. This is
until now it was high.
It was high.
It should have been changed to maximum under latest
for device link. It is maximum.
It's not maximum.
For device link, but we are not with device links here.
There you can define it. There is also maximum. Yeah.
Okay, then the default has also changed from high to maximum. But if you want to have a lower JPEG quality, so maximum is already the maximum, but you can switch to a lower here. And then you can also specify whether the transparency blend color space should be set to something. So that's it for that. So just for the ones who are using old profiles, so profiles that have been created with pdfToolbox 10, or 9, whatever, you can still use them. And the advanced color conversion policy, so the policy file, the configuration, is still being taken into account. When you import it in pdfToolbox desktop, the UI will periodically change to display the policy control again, so that you can still adjust them. But if you create a new profile, you can only use the advanced settings. Okay, next topic. Next topic is 2 new fixups, map colors and map spot and process colors are existing fixups, and both are available now in variants with in their name the addition using script variables. So both can now be controlled using script variables. This is the UI that for map colors, and basically what you do is you define the source color and the destination color, and then in this example it would convert cyan 1, magenta 2, and so forth to a color with 5, 6, 7, and 8. And I have just used these numbers so that we can see that at minimum you would have 8 different values here. If you want to create a spot color, you would have 9. The problem is when it comes to variables. So if you would want to have more than just one conversion in the Fixup, you can do that by using this plus button here. So you just hit the plus button and enter in another combination of color values. However, if you want to, in a profile that's controlled with a script, if you want to be prepared for, let's say, 10 different such mappings, then and even if you don't use spot colors, you would have to predefine 80 different variable names. Does it make sense? So you have to prepare your profile with different variables so that you can override the variables during runtime, and 8 such mappings would require 4 source code values and 4 destination values each, and that multiplied by 10 is 80. So that is not ideal. So we introduced 2 new Fixups, and these are completely controlled via JavaScript or better JSON. So this is a JSON structure that has the same information as the dialog before, but in a JSON structure. And then somebody who's using JavaScript can create such an entry in his script, or a number of such entries in his script, and then control this new Fixup, map colors using script variables. And then we will do that. And that is just the other one, so same pattern here, and then we can have a small demo. Where's my mouse? Here it is. So this is another test file that I've created, and what it uses cyan 75%, magenta 50%, and black 0% in all of these color patches, and thus the yellow varies from 0% to 100% over here. This is it's a variation of the yellow color rand, and I thought, okay, maybe. What I want to do is I want to auto-create a set of JSON expressions that would keep all the, that allows me to adjust cyan, magenta, and black, but keep the yellow. So the yellow that is different for each of the patches should remain, and I only want to convert the 3 other color rands. So it comes up with a dialog, and this dialog allows me to, for a source color, specify the source color that I want to match. And then we use a destination. Let's say we convert all the cyan to 10%. We convert the 50% magenta to, let's say, 70 so that we can see something. For the yellow, that we want to keep, so we use a wildcard, a question mark, and the black was 0, so we put the black to, let's say, 5 or 10, doesn't matter. we save the result, and now it has converted the cyan and magenta and the black and kept the yellow. So this is just an example how you can use these variables. It is, if you want, it is the Fixup is in the online documentation. Yeah. Finally, Overprint. Let me just do a demo first. Here. So 2 support cases. First one. Yeah, I don't know what it is. Some Masterarbeit, some masterclass thing, and this, if we look and we're using the object inspector, we see that there are here separation. There are some spot colors in it. Whatever pro SMS gray, somebody has probably inadvertently create a spot color here. This is to be printed on a digital printing machine. We don't want spot colors in here, so we convert all spot colors to CMYK. Unfortunately, this spot color had a white appearance, was set to overprint, and now when you convert the spot color, it's losing, in this example, its overprint capabilities, and it's now covering everything, and that applies to every page here. So this is not the intended result. So let's try, so what you can do actually, and this was created, so such problems are, I wouldn't say frequent, but they are not rare, and they are always created when a file had transparency and transparency was flattened. So sometimes the transparency flattener tries to avoid too many changes and just replaces, and it worked perfectly in this file, replaces transparency with overprint, and you can perfectly do that if you're using spot color. I will get to that later on, but you're getting problems when you then later on convert spot colors to CMYK. So for that reason, already in pdfToolbox 10, we had a process plan that's with the name Convert Spot to CMYK for transparency flattened PDFs. And when we apply that, it replaces overprint with transparency back somehow, and then converts spot to CMYK and ultimately flattens transparency again. So now we've got a much better result here that doesn't use spot colors anymore. So this is the intended result. But there are other files like this one. And when I then use this process plan, because I've learned I should be careful, I'm a pre-press, I'm working at a pre-press bureau, I'm receiving this file from a customer, if I've learned spot to CMYK, I should use this process plan. So let's do that. Then sometimes it doesn't have the intended result either. And in this case, it is so that the red here uses a spot color, but not at the top of it. However, at the top of it was overprint being used. And this overprint was now also converted to transparency, which led to a at least problematic result. Both cases came from support. and we thought, okay, it's not an ideal situation when you do automation. It's not frequent that these things happens, but they happen, and there should be a better way to see, to react on the things in the file that takes both situations into account. And then we should have some theory at least about how overprint actually works. So both situations are related to a situation where we have spot color in a file that overprints. In both cases, spot colors were converted to CMYK, and now we want to find a good way to safely convert spot colors to CMYK. And in both cases, the problems came in via overprint settings. And now this slide, I want to explain what are the differences between CMYK and spot color when it comes to overprint. So overprint, you can see that in an example over there. So in the upper part of the image, the black text knocks out, which means behind the black there is white. So the orange patch is being knocked out, which leads to registration problems when being printed. And when it's set to overprint and overprint works, then there is no such difference. The black is just in front of an orange background without any gaps in it. The problem here is CMYK can't overprint another CMYK object generally. So CMYK so CMYK can't overprint another CMYK object except when OPM is set. So you have two different parameters in a PDF file. One is the overprint parameter itself. The other is the OPM parameter, which is also called Illustrator overprint parameter, and that allows a CMYK object to overprint another CMYK object, but only if the CMYK object in front, where the CMYK object in front has 0% in the colorant. So we can see that here in the example. We have a cyan 50% patch in front of another patch that uses cyan 75, magenta 50. With no OPM, there is no overprint at all. And when there is OPM, since the upper object doesn't use magenta, the magenta shines through from the background because OPM is set, and the foreground object doesn't use magenta, so that this appears violet here. Does it make sense? So why are there, so I think people are frequently confused because these rules appear to be kind of stupid. You have to understand they come from a world or from a time when we didn't have transparency. So transparency wasn't a design thing that people could use. They were more for production, and they were invented to. So first, the RIPs were not that smart, not that powerful at these days. So it's much easier to just delete a color and replace it with a new one than to somehow keep it into account. So this was the one reason for this, and then OPM was invented to make it possible that black overprints. These rules are not intended to be used for design or so. These are really production tools, and therefore, when they are used in a design-like way, they are confusing. But anyway. Now with spot color, you basically don't have any limitations. Spot colors can overprint CMYK, CMYK can overprint spot colors can overprint other spot colors, and OPM doesn't have any meaning. So if you're using a spot color, you don't have such limitations as you have when you convert CMYK to, when you have CMYK and CMYK. Yeah. So now we understand the problem. we understand converting spot colors to CMYK is problematic because, at least when overprint is used, and sometimes it helps to just switch OPM on. So I have a spot color object, I just switch OPM on, and then it's better, definitely it is. But if the foreground object doesn't have 0%, it doesn't have anything, and yeah, maybe our engine always does so. So when you convert a spot color object to CMYK, it always sets OPM. However, if this spot color object is being overprinted by a CMYK object, it doesn't help because the OPM has to be on for the CMYK object, not for the background spot color object. So effectively, the engine would have to change an object that is not even affected by the color conversion. But luckily, pdfToolbox 10 invented Sifter, and that Sifter allows me to find out about the overprint, whether an object overlaps another object. You can find out using Sifter. And with this Sifter technology, we can create a process plan again that takes a situation, the situation into account, what objects are overlapping other objects. So a better, more selective approach where you not, as in the previous process plan, just replace all overprints with transparency. Here you can replace only those objects that really have an effect when you would convert them. So there is a new such predefined profile which is called overprint issues related to spot color if converted to CMYK. It's a long name, but it does what it says. No, there are two profiles. So yes, there is for analysis, we've got the one that I've just named, and then there is a process plan, convert spot to CMYK, replace overprint with transparency where needed, and both do what they say. I think I'm switching this. This is how that works internally. So what the process, what is being done. We can just go to our test files again. So this one was more problematic because here we went too far. So let's try the new process plan here. Convert spot to CMYK, replace overprint with transparency where needed. Yeah, no surprise, it does what it should. We have tested this with several files, and it works fine. And we encourage you to use it. You will find it in pdfToolbox 11. Any questions?